Right, I think we can make a start. Hello, everyone. I just realized that the clock started ticking, so I better start. Thank you for taking your time to come to this session. I'm Jessica Mann, and I'm part of the SRE team based in London, in Goldman Sachs. And so in this session, that I'm gonna explain a little bit about what SRE is and what are we doing. You know, what are we doing with SRE in Goldman Sachs in the bank? Now, just out of interest, with a show of hands, can you tell me if you've heard of SRE before? Any one of you? That's quite a lot. What about distributed system? Have you worked on a distributed system before, or is working on a distributed system? Less so. That is a surprise, actually. I thought there would be more people. The weight is actually more on the SRE side in this presentation to tell you what we do and why do we care. And then I touch on using the distributed system design as one of the areas that we actually focus on from the SRE team. And it's really fascinating and interesting topic. It's lots of challenges and interesting problems for us to solve. So let me skip to the end. So have a look at this slide. And so what I would like you to take away at the end after this session is that you'll find out a bit more about what we do as an SRE, and the stuff that we care about, and why should you care? Because I hope that in this presentation, I'm going to give you enough pointers and trigger that curiosity of yours, and go and research further and find out more in details about all of those points that I've actually covered in this talk. And then through which the SRE principle has got a wider adoption, and you learn something along the way. And there are some useful toolkits that I will touch on. But again, the two topics alone, SRE and distributed system design, each one of those would take at least a session and a half to cover in details. In fact, if we divide each one of those sessions into sub-areas, each one of those sub-areas will take a session and a half to explain. So I'll try my best to give you some overview of the area and give you, again, some pointers that you can take away and research further. Everything I say in this presentation, you can use your friend Google to find further, to find more information. So firstly, SRE, the term or the concepts actually originated from Google, and they apply the SRE successfully within Google. And so what are we doing in a bank? Well, it actually makes perfect sense. So the basic definition of SRE is when you ask a software engineer to engineer a solution and to design an operations function that solve problems that normally or typically is solved by hand or manually. So lots of operation teams that when they manage the production system, there are lots of manual steps sort of introduced along the process, and it's a lot of sort of experience and has gone into the operation team, and there are lots of buttons to click. So in a large enterprise, so in Goldman Sachs, we have, at any given time, there could be more than 1 million processes running at the same time. All those millions of processes, it matters a lot to the Goldman Sachs business. A lot of the business rely on the availability, the quality of the service that's provided from those processes. And there are thousands of developers within Goldman Sachs. And then add on many operation teams managing all those production environments at the same time. It's a big challenge. It's really big, interesting problems that we have to solve. Applying SRE is actually take on it from a different angle, and we apply the engineering, the hats-on, and some of the best practices and the principles of SRE applying to the operations. And it actually helps us a great deal to solve all those problems. And you'll see, hopefully it will make sense to you as well. Security control, again, is something that we care about. And so all of that is basically to ensure that reliability is applied to the existing software. Now, what is reliability? So behind that very simple word, I present to you the production hierarchy of needs. So this is actually the pyramid. It's modeled based on, I don't know whether you've heard of the Maslow's hierarchy of needs for human. Some nods there, great. So what that is, the Maslow's, the hierarchy of needs is you have the physical layers at the bottom, that you need food, you need health, you need sleep, rest, and without that, you can't really go any further. But once you have that, once you address all that, and then you go to the next layer to think about safety, you need a house around you, you need clothing to protect you from the weather, and then all the way to the top to think about self-accomplishment, fulfillment, achievement, what you do with your job, that kind of thing. So the idea is that the higher layer should not be attempted until the lower layer are addressed. So applying that kind of that principle into reliability. So these are the areas that we care about. Monitoring is key here. And why is it key? Well, without metrics, without data of knowing how well your system performs, you're kind of running blind. If I say that your system is not very good, what does that mean? And so having metrics to actually give you quantifiable measure into your system, it helps a great deal. You talk common language to other people with other teams, and it makes sense. And then after that, then you think about, okay, when there's an incident happens to your system, how do you recover very quickly? And then once you've done that, then you think about, okay, what is actually causing that incident so that it will not happen again? And then you apply that into your testing, capacity planning, and then all the way before you think about adding features and how do you shape your product into something that you can offer to your users and your clients. I hope that makes sense. Now, that is all in theory. So how do we actually apply that in practice in Goldman Sachs? So the SRE team care a lot about monitoring. I hope you got that point already. And so we work with, so there is the third point there, the SRE dev alignment. And so we believe in not having that organizational barrier between the operations team and the development team. You should, talk to each other so that the development team would tell the operation team what they're working on, the design, and so that the operation teams would know what to do when there is an outage, when there is a recovery that's needed for them to press a button, and also involve in right from the beginning when they're actually designing the system. And that's where the SLO and the SLI, the service level objective and the service level indicator, come in place as well. And because it's important to define what is the right level of reliability. Now, 100% is not the right answer. Because with 100% of reliable, that means your system will never get down or your latency will always be below that threshold. Now, to achieve that is a really high cost. And you have to ask yourself, do I really need that? Can I afford for the next 30 days, if my system is down for 4 hours, 7 hours, does it actually impact my users? And if you have that figure in mind, then it makes your life much easier, and then to decide on how you plan your deployment and how you plan to release your features. And when it comes to the decision making, whether I should release more features into the product in the next cycle, or should I focus more on the reliability side, having that SLO defined would help you a great deal. Incident management and postmortem. So SRE likes to ask questions. And so this is to ensure that the right questions are being asked so that you get to the bottom of all those incidents in a way that the goal is such that the same incident caused by the same root cause will never happen again. So that is what we're trying to get at. And of course, when it comes to root cause analysis, when you do the postmortem, then comes the actions. They're usually associated with a set of actions that the development team or operation teams or the teams that your system depend on will need to go and fix. And so we need to also do the post-mortem action tracking as well. So we work along with the development team to make sure those actions are being carried out and give it a timeline as well. And so depending on the severity, we might need a response from those actions or have them fixed within 3 days or something like that. Now, tooling is a wide term, generic term. So basically, what I mean by that is the right tooling will help you a great deal. So SRE also look into what is the right tool can be used for any of the above. So just to give you an example, now this is a generic term. It's actually come from one of the products, the production system, that we've added the metrics already. So SRE has actually helped to add in the probes and to gather the metrics out from the system, and it's very tiny little letter there, basically says latency. So this is measuring the latency, and the threshold of the latency that we're aiming at is 1 millisecond. So for this, the SLO, in this particular case, is basically for the 30 days period of time, no more than 1%, so that equates to about 7.2 hours. No more than 7 hours. For the latency is within the 7 hours. So is so over the 30 days, that no more than 7 hours accumulated, that the latency is more than 1 millisecond. I think I got there. I hope I haven't lost you. So basically, we need to measure the latency quality. So to ensure that majority of time, 99% of the time, this service can respond within that threshold. And interestingly, there is an error budget here. Now, I'm going to explain the terms a little bit further before I go back to the graph. So as I mentioned earlier, the SLO is to help you to define what is the right level. So is it 99% or 99.5% or 99.9%? So usually people use the 3 nines or 5 nines to define the SLO. So that is bound on the SLI. So SLI is the quantitative measure of some aspect of your service, like the availability. Is it up? Is it down? The latency of the request. How quickly do you respond? You measure the time. Error rate. How many of those HTTP response is not of the 2xx in the 200s? System throughput. How much time is taken from your system to execute whatever operation it needs to execute? So all of those is a quantitative measure, and based on those, you put on a bound, put on a target. So like the previous example, that bound is 1 millisecond, and within the 30 days, and it's 99% of the time that the latency will not exceed the 1 millisecond, and so that defined your SLO. Now the error budget is then your SLI minus the SLO. So going back to here. So in this graph here, this third one, apology with a very, very tiny little letter, what it says is latency SLO performance. So at the bottom is that flat line there is the SLO target. So that is pointing to 99%. And this line here is the SLI that's measured at that point of time. And so we can see that is pointing to 99.75%. So that SLI, that percentage, is measured based on the success, the number of successes or success events, over defilet events. So defilet events in this case is all the responses that we can measure the time on. So we know the time that's taken for that particular request. And then out of those, that the ones that have the latency or the time taken is less than a millisecond, and that is your SLI percentage, and then times 100%. And so you can see that most of the time is above the threshold, but there is a dip there. And with SLI minus SLO, and you get the error budget, and that gives you a sense of how much time or how much leeway that I have in order to release changes. Should I focus more on the reliability to fix it up in such a way that it will reach back up to the SLO? Or can I actually, it's been doing so well that we're more comfortable about releasing this new change that might destabilize the system a little bit. But we can probably afford that the system to be down by 4 hours in the next 30 days. And in which case, then you're within this error budget and you can burn that. And so now it becomes very clear, and you can quantify your argument. If you go to your, let's say the operation team, go to the development team and say that, you know what, you should slow down your release development, your changes, because the system is a bit unstable. And they will look at you and go, well, if they're good, they will probably listen to you. But if they're not, they will probably say, show me the evidence. And here is the evidence. You can just clearly show them, right, look, this is how much you can do, so on. So that's how powerful that is. And now the SLI depends on metrics. So you need the data from your system. With metrics, you have power. With power comes responsibility. So with good metrics comes great monitoring. So it will tell you a good story. You can quantify and all good things that I just mentioned earlier. However, if it is very easy to measure everything, and you have to ask yourself, of all these metrics that I'm gathering, can it actually give me the answer of, is it impacting our users? Is our users happy or not? Is it impacting the availability of my system? What is the story the metrics is telling me? If it shows that the metrics is the CPU is high, is it just because that there is more load on that particular day, but my system performed happily? I mean, my users are all happy. There was no complaint. So should I be alerted on that? So ask yourself those questions, and because before you know it, if you have too many of those bad metrics and you have setting up the alerts based on those bad metrics, you're gonna, before you know it, you have about 100 alerts every day, and 1 or 2 of those might be important, and guess what? They will be missed. So in summary, we have these are the things that we have been doing. The SRE team is actually quite new. It was officially launched about a year ago, and since then we've been applying all these practices into the firm. And we've run the SLO workshop, as you can imagine. Just a few sentences. It's very difficult to explain what SLO, SLI, and error budgets and all those things, and also explain that into real term. We tend to run the workshops that has solid examples and use cases and exercises people can actually go through in more details. We already have SLO dashboards that is being monitored by the SRE team, and as you can see, the previous one, that's actually a real dashboard. We do involve in the design changes and some of the decision making, so we actually work actively with the application team. We have already paired with a few product development team. Already we partner with them. We have daily scrums, and we involve in all the decision making and make sure that the support are being met, and we understand how the system works. Post-mortem action tracking, root cause analysis, again, we were there to ask questions, ask lots of questions. One thing I'd like to point out is that with the incident management is a no-blame culture or process, knowing process. So what we're trying to do to achieve is really get all the data from everybody to get down to actually what was that one change or what was the cause at the very beginning that caused this particular incident that happened. And so that we can then know what's the right actions to take in order to prevent it into the in the future. And then we also look into the distributed system and architecture design as well, because quite often when we look at the incidents happened, the outage, is a lot of them is thinking about, okay, a change has been applied, but what was the process for that change to have been applied? What was the deployment mechanism? What was the rollback strategy? And also the client and the server communicate with each other. How could a change in the server broke your client? What was actually the design in place at the beginning, such that we have this outage today? And that's why we look at the distributed system design, and it's a very interesting topic because there are so many technologies out there that so many different concepts people apply to the distributed system design, and people have different interpretations, different flavors and or favorites, sorry, and they've got their opinion about how it should be designed. And so what we tend to do is look at the existing design and again ask questions and think about the observability. Do you have monitoring in place? Do you have metrics? How can you tell if your system is up or down, and how do you measure your latency? Scalability, if the load is increased, how do you then scale up in order to fulfill the extra load? And whenever there is a change, how do you manage that change? How do you release the next version, and what is your rollback strategy? So asking all those questions, and then we started to see that there are actually gaps in the existing design, and we start to so again applying sort of being a software engineer, applying the engineering thinking on, we could actually build some building blocks to help our developers. And we identified that recently I'm looking into the gRPC based solution. So that's quite interesting. Has anyone heard of gRPC before? Okay, a few people. Not many. So gRPC is created by Google, again. And it's basically a framework for microservices architecture, and it's in a sort of a layered RPC system. So we have so in the RPC system, the layers is roughly at the bottom. You have the transport layer, so that's the HTTP. So for gRPC, it's over HTTP2. Although there is talks about HTTP3, I think that's probably more or less ready for HTTP3. So that's HTTP as a transport, and then on top of that, we have the channel that would basically take the request and then route it through to the transport layer. And then the channel is basically listening the stub. The stub is the next layer up, and the stub is where the service definition is actually defined there. When you want to call a service, a function within the service, you go through the stub to call that. And that stub is generated by the IDL, is the interface definition language. In gRPC, it uses protobuf. It's short for protocol buffers. And that is the interface definition language and the message format. And that is programming language agnostic. So it's basically has got its own format, and it's strongly typed, and each one of those, the data type is versioned. And you can basically use that to generate different languages. So it supports most of the major ones, really. So Java, definitely, and it supports Python, it supports C#, C++, and Node.js as well. And because it's strongly typed, and versioned, it is to ensure that, from the client side, when I send over the bytes over to the surface, I know that that is what is expected from the surfaces. And so that makes it a little bit better than the loosely type, like JSON over HTTP in REST, as most people use. And out of the box, it supports TLS-based security. And so that is kind of encourage people to think about security up front as well when you design your distributed system. And because in protobuf, it uses binary format to transmit all the data in between the client and the server. And so it makes it very efficient when it comes to serialization and deserialization of the payload. I think I covered most of the points there. And just to illustrate, just to give you an example of what it looks like, and this is a protobuf definition. Uses Proto 3, and this is the latest version. I think it's slightly different from Proto 2, so you have to provide the syntax, which version you're actually using. And this is a package. So this very, very simple example is, if you like, is a people directory. And it has got one service, and within this service, you can call create person to submit a person into this directory. So the client can construct a people request, and then call create person to put this person into the directory, and you get back a set of the replies. In this particular scenario, you can imagine it will reply back, send back all the names from the directory, for example. It might be useful. Notice it's a stream, so it's more than one reply, but it's basically streaming back. And this is the request type, what it looks like, and you can see that it is typed. They're both string with the first name and the last name, and it's versioned in such a way that I cannot have another field that with the same identifier with it. So this is like an identifier to those the fields, and the same for the reply. So again, there is another benefit of using the protobuf is the response type is also well defined as well up front. So this is like the contract between the client and the server. And so to code from the client. Now, once you've got the protobuf defined, you can then use the protobuf compiler, the proto-C, to generate the stubs for you. And then with that stub, so it can generate into the language of your choice. And in this particular case, it's Java, of course. And then you can make use of that stub to call the service. And this is what you need to do. Firstly, you need to obtain the channel. Like I mentioned before, you need the channel to talk to the transport layer. And you have the channel builder. You give it the endpoint address, and then you give it the SSL context for security, and then you build it. And then once you've got the channel, you use that channel, then you build the stub. And that stub, in this particular example, I'm using a blocking one. Blocking means that basically you wait until you get back a response. But there is also non-blocking stuff that you can make use of, and it's more like an asynchronous kind of RPC. Cool. And then now that you've got the stub, the next step is your business logic with the client. What do you want to do with it? What do you want to this service to do for you? So in this particular case, I wanted to add this person called David Buckingham into the directory. And so by using that generated code, I can easily just build this people request, set the first name, set the last name, and send it off. So with this stub, I can call the service directly, and I send the request. And voila, I have the reply back. And then from this reply, then I can do whatever I need to do with it. Easy, right? So then the server side is as easy. Out of the box with gRPC, it comes with the Netty application server, the embedded server, but you can plug in your own of other different flavor of your application server. But you do need that to host your service. So the server, you then ask the server to listen on this particular port, whatever port you want to select, set the SSL context and give it the certificate file, and make sure that the client authentication is required. So again, just a few calls, then you have the security that is set up for that server. And then all you need to care about, again, is the business logic. So you know what the requests look like, you know what the reply you need to construct, then you fill in the in-between, the ... In this particular case, it doesn't really matter what it is, but I hope you get the idea. So yeah, I think that's all we need to say. Now, let's go back to here. Of course, in this particular example, we have one client and one server. And I know exactly where my server runs. But in the real world, it's not like that. In a distributed system, there are many services running at the same time, and there are lots of clients trying to connect those services. And so, yeah, I hear you ask, what about service discovery and load balancing? So that topic, again, that itself will probably take half a day to explain and to go into details of a different type of load balancer and the considerations that take into account of, what are the things that we need to consider to choose what the load balancer, the load balancing strategy we should apply to our system. But just to, again, give you some pointers, give you a favor of the load balancer, what we look into. So we've considered the proxy type of load balancer. That is the typical type of load balancer. You have a proxy in between and acts as a trust barrier between your client and server. This typically used if you have the services behind this boundary and you offer the service to the internet. So the client can be anywhere, everywhere, and open to the public, and you need this barrier to route the request into your services and protect your services. With that, it's a great concept. We have the load balancer that could take care of that, and the proxy will route everything and take care of that. And it will know the load of your servers and know what to do. You can configure that layer. However, it is in the data path, which means that everything has to go through the proxy. And so that when you consider scalability, when you consider resiliency, it's not just your server you need to consider. You need to consider your proxy as well. And so then the scale, how many clients you can support, very much depending on your proxy layer. And then versus proxy balancer, we have client-side load balancer. And this is one type of the client-side load balancer. You probably hear a lot of service mesh nowadays when we talk about cloud. And in the service mesh environment, you have basically it's services talk to other services with the infrastructure can be configured. And the configurations can happen within the sidecar. And so the load balancing can actually happen within this sidecar. So in this particular example, the client and the server, they're both client and server. They're both basically services talking to each other. And the logic can then be distributed, basically. And the logic will be implemented on the client side. And the sidecar will know where the services are and how to talk to each other. And so that introduces complex logic into this sidecar, and also for each client now you have the extra process you need to look after. And it's also still in the data path. So whatever you send, you have to go through the sidecar before you reach the surface on the other side. And then there is this, which is very interesting. So it's also a client-side load balancer. And we spend a little bit more time on this looker-side load balancer because it seems to fulfill a lot of our requirements. Because firstly, you have the load balancer out of your data path. And so how this works is that the client would go to in fact, I've got a diagram to illustrate that. So you have the client go to the looker-side load balancer and saying that, give me the addresses, give me the endpoints. The load balancer saying, here we go, here's the list. And behind the scene, the load balancer would have done the discovery, would have done the health check. So it knows that this list returned are the ones that are serving, are the ones that is already healthy. And so then the clients just need to simply take this list and then connect. And so the logic that needs to be implemented at the client side is basically the ability to talk to the looker-side load balancer and then select the returned address and then talk to the server using the address directly. And so this no longer in the data path. The logic is now centralized. It's kind of all within this one looker-side load balancer. And the logic within, so for each client, is now much simpler. And so this is one of the load balancer that we're actually currently spending more time on and trying to make that into a solution and one of the building blocks for our developers or engineers to use. And here are some, just basically, it's a summary of the different types, and there are pros and cons for all of them, and I think I cover most of them. And at the end, I think this is probably the most interesting slide of the three. So for the proxy load balancer, usually is when you have open internet clients connect to your service, you do need that trust barrier between the two. And the surface mesh the sidecar typically used in the surface mesh environment. And also, having the sidecar is quite good when you have binaries that you cannot modify. So the binaries that can be from legacy, that you don't have a source code anymore, or come from a vendor software, then having the sidecar, you have the control, but you don't need to worry too much about modifying the binaries. The looker side is particularly good for microservices that it fits take a lot of the boxes that the SRE look for in terms of reliability, quality. And so we almost consider that as a default if your application or your system does not rely on a trust boundary, or it doesn't rely on, does not have dependencies on unmodifiable binaries, then looker side is probably your choice. So we are currently building that as a solution to our developers, and so this is another thing that SRE do, and so we're engineering solutions. Okay, remember this slide? That seems ages ago now. So hopefully you get a sense of what SRE does, and what are the things that we care about, and what do we do? Why is it interesting? I personally find everything very interesting. And hopefully some of the points that I cover will trigger you to think about how does that apply to what I do when wherever you are. And look it up. Do look it up, these SRE principles, and see if they're useful. Apply it. I suggest that to your team when you go back. And some of the terms that I've mentioned in this talk, again, they're all widely available online. You just go and search for them. You should get a lot of hits. And I'm available after this talk if you want to talk to me more. I think I'm bang on. We've got a few minutes left. So if you've got any questions. Yeah?
What is your favorite service mesh implementation? Like
Istio
or something else?
I don't have a personal favorite as such, the surface mesh, but Istio is one of the ones that we look into a bit more. Yes.
And are you currently using it?
There are some parts in the firm, yes, it is using that. Yeah, I'm pretty sure. So I think there is the Cloud Native Foundation has got a few sort of graduated projects, and I know Envoy is there, Kubernetes is there, and Linkerd is the other one. Yes. Yeah, I've actually started looking into Linkerd as well, and that's implemented in Rust. That's quite interesting. So, yeah, so it's more, yeah, we need to invest more time into the different solutions. What about you? Do you have a favorite?
No, I don't.
All right, okay.
That's why I was curious. Like, Istio seems to be the winner here because it's backed by Google mostly. And so I think it will be the story like with Kubernetes. It was like really bad in the beginning, but then Google fixed it and now it seems to be the winner. So I think it will be the same story.
I think it's a matter of time. It's evolve when more and more users using a specific type of
nobody
technology. And
is really using it in production.
yes, exactly. It needs to be field tested, a lot of these things. Any other questions or discussions, comments? Your personal experience?
I have a question. So actually, what do you do as SRE? Because you talked about several topics.
Yes.
And you are a SRE team just setting the standards for other teams to map, or you helping them implement those strategies
Helping
or
them.
use cases, or you implement them it for themselves, or how it works?
Both, I think. So we educate, I guess, is raise awareness of some of these concepts that we have. We run the SLO workshop, as well as we actually implement some of the Prometheus. We use that as for the monitoring, as one of the tools for the monitoring. And we work closely with a team who can actually offer Prometheus as a service in the firm, for example. And make sure that whatever we think that is a good practice that would be useful, that it can be done. And so we go to the teams who can make it, who can make it to work within the firm. And then for parts that we can do ourselves, we would do it as well. So for example, the gRPC load balancer, the implementation, the building blocks. So I'm actually actively working on that project today. That is to implement something that people can actually make use of. But at the end, so SRE will then help with the onboarded product teams or development team, and to make use of those tools that we either produce or we help other teams to create. And then through those, then to make sure that then the developers can apply all those practices and ensure the reliability in the system. And then we can hold the pager for them. It's kind of make our jobs easier in a way. But we help engineering into the solutions of all aspects. So that's what we do. But communication is key. We do, so like I mentioned earlier, we have to break down that barrier between us and development team. So operations and development should work together, and to have that transparency as well, and talk the common language. I think that's key. That's what we do. Okay. I think that's it. Well, thank you very much for your time.